Okay, so this is problem number 10. According to a study conducted by a statistical organization, the proportion of people who are satisfied with the way things are going in their lives is 0.82, so 82% of people. Suppose that a random sample of 100 is obtained. So by the way, this is our uh, P, and we got a random sample with N. So this is our actual P, by the way, not the P we obtained from our sample. So it's not P hat. So the first question asked, suppose our random sample of 100 people asked, are you satisfied? Is this qualitative or quantitative? So explain. So I've gone over here, and remember with me that qualitative we called categorical back when we talked about that. So that would be something like my eyes are blue or green or brown or purple. So in this case, we have answers of yes or no. So this would be qualitative, not quantitative, which would be a numerical answer like 0.5 or 0.8 or 1 or 2 or 1 million, something that is a numerical answer. So our answer to this one is D. The response is qualitative. And by the way, so we knew at this point it wasn't C because that's quantitative, and we knew it wasn't B because that's not quantitative. But the reason it's qualitative is not because the people can be counted, it's because the responses can be classified. Remember, we could put them in buckets of blue eyes, green eyes, purple eyes, whatever. So in this case, our two buckets or two categories would be you're satisfied or you're not satisfied. So that's what makes it qualitative. You can put it in different categories or buckets. All right, so going on to part B, explain why the sample proportion p hat is a random variable and what is the source of the variability. Okay, so if you look, the differences in A, B, C, and D, this first two talk about the variable p hat varies because you're gathering different samples, and so the proportion of people that are satisfied might vary. If you got a group of people from jail, they're not going to be very satisfied in that sample, versus if you got people at Disney World, they're going to be super satisfied. So your proportion of people that are satisfied is going to vary from sample to sample. C and D talk about you're picking a random person off the street. Well, I mean, you might pick some random people in your sample, but that's not what p hat represents. P hat represents the proportion of people in a sample, like collectively, what is our proportion of people, not any one particular person. So then the differences between A and B, this one is due to the fact that different people feel differently regarding their satisfaction, versus part B, people may or may not tell the truth. What? Like you hope when you're sampling people that everybody is telling the truth. Um, you do run into some issues where people might lie about something, especially when it's a sensitive topic, like um, I don't know, there's lots of sensitive topics right now regarding gender and race and stuff. So that's a different part of statistics where you talk about how you account for people not always answering questions truthfully, but that is not something we have talked about at all in this class. So it just is based on the fact that people in Disney World or might feel like their life is great, and people in jail might feel like their life is not great. So the variability is different based on different samples. All right, so part C. Okay, so it says describe the sampling distribution of p hat, the proportion of people who are satisfied with the way things are going in their life. Be sure to verify the model requirements. Okay, so I don't love the way they did this, but whatever. So rule number 1 is that your N is supposed to be less than 5% of the entire population. So that's rule number 1. N is supposed to be less than 0.05 times N. Well, the interesting thing about this problem is they never told us what our population was. They just said of people. proportion of people satisfied with the way things are going. And so I don't know, is that people in the world? Is that people in the United States? Since they didn't specify, we're just going to assume it's people of the world. So whatever it is, 5% of people in the world is going to be a heck of a lot larger than 100. So we're just going to go ahead with no more than 5%. We were good with that. We're going to assume it's smaller than whatever the population is. And then we have to go to rule number 2. We have to check our n times p times 1 minus p. So our n is 100, our sample size. Our p is the 0.82. So 100 times 0.82 times 1 minus 0.82 comes out to be 0.1, no. Okay, I didn't multiply that times 100. Hold on, my bad. Going back to my calculator. Comes out to be 14.76 exactly. So does it say what to round it to? 3 decimal places as needed. This only has 2 decimal places, so that's going to be what it is. And that is indeed greater than 10, which was our other rule, that has to come out to be greater than 10. So we met both of our rules that you have to pass in order to decide whether or not something can be normal. So since we passed both blanks, both rules, right? Then number 2 down here, this is approximately normal with mu. So our mu p hat is the same as our p, which in the original problem they told us was 0.82. And then, and sigma subscript p hat is, we know the formula adjusted for that for the sampling distribution is p times 1 minus p all over n. So that's 0.82 times 1 minus 0.82 all over 100, which comes out to be, yeah, sorry, looking back in my calculator, 0.038487. So to the nearest 3 decimal places is 0.038. Okay, so in part D, it says the sample obtained in part A, what is the probability that the proportion who are satisfied with the way things are going exceeds 0.84? So we're finding the probability that X is greater, well, really P hat. The probability that P hat is greater than 0.84. And so you go to your calculator and you're going to do normal CDF, and you're going to do the 0.84 as your lower bound. You're going out to infinity, so 1 times 10 to the 99th is your upper bound, and then your mean is the 0.82, and your standard deviation is this number. Now, I will caution you, on these standard deviations, be sure that you're using sufficient decimal places, because if you only go to like a couple of decimal places, it will return a wrong value. It'll be off by a little bit, and MathXL will get angry at you. So make sure you're using enough decimal places. So that gives me back 3013297. So to 4 decimal places, that is 0.3013. Then the last question, part E, we're finding the probability that 75 out of 100, so this is going to be the probability that P hat is 75 or fewer, so 0.75. Now remember that 0.75 is coming from the fact that we're talking about 75 out of 100. You can't use normal 75. You have to actually do the proportion. Remember we talked about you got to be using consistent values. It wouldn't make sense to use 75 and then 0.78 and 0.041. So 0.75. So fewer than 75 people satisfied with their lives. And so we put that in our calculator here, the normal CDF. And then we're doing -1 times 10 to the 99th and 0.75. And our mean is not 0.78. This is what I was working out. Grant's problem. And so this is 0.82. And this is 0.0384187. And that comes out to be 0.034. 0.034225. Okay, so to 4 decimal places, 0.0342, which is unusual because it is less than 5%. 3 would be less than 5%, so this one would be unusual. If you get a number that's greater than 0.05, then you're going to have to say it would not be unusual because it's greater than 5%. So just keep in mind your problem may be a little bit different than mine.